Objective 9.6, Complex Fractions. In this objective, we want to be able to simplify complex fractions involving rational expressions. Complex fractions are simply fractions within fractions, and so our goal is to simplify them as much as possible to make them look a little less unruly. So here's our first example. We have the expression 2 over x plus 2 all over 1 over x plus 2 plus 2 over x. So as you can see, it's pretty complicated with all these fractions inside of fractions, and it's kind of a mess. But our goal is to try to simplify this. So step 1 is to combine any rational expressions that need to be so that we get a single expression in the numerator and a single expression in the denominator. So we want a single rational in the numerator and a single rational in the denominator. Now we already have this 2 over x plus 2 in the numerator. That's a single rational expression, and therefore we don't have to change anything there. But then in the denominator, we have this addition of two rational expressions. And so we're going to need to work that out so that this can become a single rational expression. So now we're going to fall back on what we were doing in the last objective, and we're going to add these two rational expressions together. So that's going to look something like this. First, we're going to decide on our LCD, which using x plus 2 and x is going to give us an LCD of x times x plus 2. There's no common factor here between these two denominators, so we're going to use both. And so in our next step here, we're just rewriting the fractions, the rational expressions, so that they have that LCD. So that means multiplying the first fraction by x on the top and the bottom to get x over x times x plus 2. And in our second fraction, we need to multiply the top and the bottom by the x plus 2. So the 2 that was already here is going to get multiplied by x plus 2 as well as the x that was in the bottom. And so now if we combine, you can see here we would have to distribute the 2 to the x and the 2, and that's where this 2x plus 4 is coming from. And that's being added to the x that was in our first numerator to start with. So when we combine everything together, we end up with 3x plus 4 all over x times x plus 2. So that now is going to go in for the denominator. So now we have a single expression divided by a single expression. Okay? So moving on to the next slide, here's where we're at this point. Step 2 is to consider the fraction that we now have as a division problem and divide the rational expressions. We've said many times in the past that fraction bars like this are just like having division signs. And so we actually want to think of this as this rational expression being divided by this rational expression. So we're going to write that a little bit differently so it's a little more obvious to see how we should proceed. And now we can go back to what we did 2 objectives ago and work this out the rest of the way. So we know with division, we're going to change to multiplication by multiplying and then flipping our second fraction. And now we can cancel common factors. So that's going to be the x plus 2 here that can cancel with the x plus 2 here. And finally multiply across to end up with 2x times the, 2x over the 3x plus 4. Okay, that is our final answer. That is our simplified form of that whole mess that we started with. So it's really just a two-step process. The first step is to make sure that expressions in the numerator and the denominator are combined into a single expression, and then the second step is to actually work things out as a division problem to get to your final simplest form answer. Let's take a look at another one just to make sure we've got this down. So this time we're looking at 3 over x minus 4 all over 1 minus x plus 4 plus 3 over x plus 1. So again, if we're trying to look for combined expressions, our top already is a single expression, so we don't need to do anything with that one. But our bottom is going to need some work. We need to take these two expressions and actually add them together to get a single expression. So again, least common denominator. Since there's no common factor in these two, we're going to use both. And so that means that we need to take the 1 here times the x plus 1 and the 3 here times the x minus 4. The 1 times x plus 1 will just give us the x plus 1 right here. And the 3 times the x minus 4 we can distribute to get 3x minus 12. And so now when we combine all of that together, we get 4x minus 11 all over x minus 4 times x plus 1. So that now is what's going to go into our denominator. And so now that we have a single expression over a single expression, we can rewrite it as a division problem, which means really rewriting it as a multiplication problem. And then we can cancel out the common factors, which in this case would be the x minus 4. And so now the 3 times x plus 1, we can distribute the 3 to get 3x plus 3, and the 4x minus 11 will stay as our denominator. Okay, that's all there is to it. Why don't you give one a try? Pause the video for a moment while you try it, and then come back to see how you did when you're ready. All right, let's see how you did. Hopefully you have work that looks something like this. Your first step would be to combine the expressions that are in this denominator, because again the numerator is already a single expression. And when we combine those, you should end up with 3x plus 1 over x times x minus 1. And then we can take that, think of it as a division problem, which means rewriting it as a multiplication problem. And in this form, we can see that the x minus 1s will cancel out, and so we're left with 2x over 3x plus 1. So, after a couple of pretty long objectives, I'm giving you a break today with a fairly short one. That's all there is to this objective, just being able to simplify those kinds of complex fractions into something that's more simple and more easy to work with, and just a nicer form to look at. So if you have any questions about what you've just seen on this video, please make sure you ask during class. Otherwise, you should have enough information that you can be working on your 9.6 practice in the next class. And then when you have 9.6 finished, make sure you get it checked off by me. And then with our adjustment to the calendar, remember we're going to take the quiz 9B now, but it's going to be a little bit different than originally set up. So if you look at the practice quiz 9B in your booklet, you're really just focusing on problems 1 through 8. You don't need to worry about 9 through 12 right now. Just practice with problems 1 through 8 on the practice quiz 9B. And that will help you to prepare for the quiz 9B that you should be taking here in a day or two. And then remember, that's as far as we're going to get for right now. Once we complete this, we'll start moving into some semester test review, and hopefully we'll get prepared to get some good grades on that test. So we'll see you next class, ready to continue working and to start preparing for semester tests.